was the beginning, and one of the authors of the book Kotlin in Action. Big round of applause, please, for Svetlana. Welcome her.
Hi, everyone. Thanks a lot for coming to my talk. Does it work correctly? The recording? So yeah, we can continue. Then, okay, let's start. And today we are going to discuss the Kotlin programming language. My first question, who has some experience with Kotlin already? Not many? Okay, then this talk might be interesting to you because I will give some general introduction and introduction to some new features. So you might be interested in what's going next. Okay, let's start with recent news. They told me that I have to use this one for this. Maybe you've heard that yesterday Google announced Kotlin as a first-class language on the Android platform. We are very happy at JetBrains. It really means that Kotlin will have very big adoption in at least in this mobile development, and there were many people who told me that, yeah, I love Kotlin, that's very nice, but Google doesn't approve it, so I can't use it because my management told me that unless Google approves it, etc., etc. So now everything is great. Okay, but then there's a question: who here is not an Android developer? Quite a few, and you might be interested. Like, does it mean this language is now for Android only? And our answer is no. At JetBrains, we want to share this idea that we want Kotlin to be a language that is useful, that is convenient, that is very nice for usage for you all, not only for Android or etc. And to some extent, if you're not an Android developer and you hear this news, it can be some kind of improvement that Kotlin is good enough, mature enough. So even Google announced that, okay, now we are good with having Google as a main language for Android platform. That means that for other platform, it might be at least interesting and an interesting option. Actually, we have even 3 platforms for the language. We have Java, the main platform, that covers Android as well. Also, we can compile Kotlin to JavaScript. So you have this statical type language for JavaScript. And recently, we have also the 3rd platform, Kotlin Native. And it now is under development, so we will be able to compile Kotlin to the native code. Today, we are going to discuss Java platform, compiling Kotlin to Java bytecode and using it whenever you would use Java language instead. Some facts about Kotlin. We released it, the first version, last year. This year we released the version 1.1, and at the half part of my talk I'm going to cover the major key feature of this second release. It's developed in JetBrains, and we use in JetBrains it now for quite a lot of projects. Also, it is used in many other companies. And before yesterday, I have these statistics that approximately half of the usage were for mobile platform, and another half for other platforms, for just Java in general. I hope that now these statistics will change, of course, but still we want to have the language that is suitable for your needs, even if you're not a mobile developer. Also, another fact that Gradle last year announced that they will soon allow to write Gradle build scripts in Kotlin in a statical type language. So now this feature is under development, but they are going to release it soon. So now I want to discuss a bit about why it works like this. So why Kotlin is popular, why someone is interested in going through it, and why you could be interested in developing in this language as well. For me, I would say that two things define this. Kotlin is a modern and pragmatic language at the same time. And at first, I want to explain you what do I mean by this word pragmatic. And after that, we'll discuss the modern term. So this language is developed in JetBrains. JetBrains is the company standing, for instance, behind IntelliJ IDEA. And that means for you that you can expect really good tooling for the language. So if the company is developing the language and the IDE at the same time, it's much easier to provide a good tooling because it's just the team is sitting at the same floor. So if we're talking about the Kotlin compiler, it's actually the same team. So it's much easier to, to implement all this functionality. And for now, the feature coverage for Kotlin can be compared to feature coverage for Java language. So you, almost everything you used to have for Java in your IDE, for instance, IntelliJ, you have in Kotlin. Kotlin is compiled to Java bytecode, and that means that it can be mixed with the Java code. And the key word here is easily. And I would emphasize that it's really easily mixed. So it's indeed the case that you can mix Kotlin and Java in one project. And you can also not only call Kotlin code from Java code from Kotlin code, because for many new JVM languages it's the case, but also you can call it the other way around. And that is, to some extent, the most important feature of the language of these modern JVM languages that distinguishes Kotlin and gives it a chance to, I don't know, to conquer the hearts, to conquer the people. Why? Because you can really, you don't have to rewrite your Java project if you want to start using the new language. You can just start adding Kotlin very slowly and continue to develop partly in Java, partly in Kotlin. And it works. And it's not just works somehow or occasionally. It was a very important design decision. So at the very first stage, every solution, every design decision that was made about the language was made with this idea in mind: how to provide a very easy compatibility. And so that is extremely important for us. Okay, now I've tried to explain what it is. What do I mean by this being pragmatic language? The language not for the academy, but for industry, for you. And now I want to share what do I mean by a language, like what do I call a modern language? And for me, this modern thing, it applies not only to Kotlin. If you look at many other JVM languages, like Scala, Groovy, Ceylon, they all share the same characteristics. They all are concise, safe, and expressive. And Kotlin is no exception here. However, Kotlin is different to the previous one because it is very easily compatible with Java. Can I call Java the modern language? I doubt it. I think no. Let's start with the concise thing. In Java, even in Java 8, you still have to write such classes. You still have to declare the data class, declare explicitly the fields, the constructor, the getters, and the setters if they're present. But now, in all these modern languages, Kotlin is no exception here. We know how to express the same idea better, in a nicer way. Now I want to introduce you to the tool, Java to Kotlin Converter. And it is indeed a very nice tool how to can start developing in Kotlin. So you just open your IDE. And if you don't know how to express something in Kotlin, because you are new to this language, you can just write the same thing in Java and convert it automatically. You won't always get a very idiomatic Kotlin maybe, but still it will be the Kotlin code, then you can do something with it and change later. So in this case, our Java to Kotlin converter produces this result. It's much nicer, it's much concise, and again, it's not with the feature of only Kotlin. Probably if you might be tired of this functionality already because it is present for most of all the modern languages. The syntax might look a bit different, but in general, the idea is the same. We know how to express the same concept in a more concise fashion. Here we declare this, the same code is hidden under the hood. So for this class, the constructor together, so two fields are generated in the bytecode. And Java usages are the same. But if you want to change your getter, to change something, you can do that with Kotlin syntax. But for the most common version of this class, the code stays very, very simple. And in Kotlin, you can add very little modifier, data modifier, and that will generate a bunch of new useful methods for this class for you. Because with data classes, usually we have to generate equals and hash code for them. So adding data generates these automatically. My other point was about safety. Remember, I had this model language, and it's concise, safe, and expressive. So now, about safe. What does it mean to be safe? You've probably also have heard about this term. It's so-called $1 mistake. And what's the problem? You have some error, and this null pointer exception. And even if you click on details, you do not have any additional information because it's often hard to say where the problem occurred. And this name was invented by, was proposed by Svetlana Isakova, who invented the null reference in the first place. And he told that we cannot count how much money we spent on solving this problem. And the modern approach that, again, is not unique for Kotlin. So lots of languages do the same. Even Java 8 have some solution for that. So the modern approach is to make null pointer exception compile time error, not runtime error. So we want to prevent such type of errors instead of fixing them later. And for this problem, Kotlin proposes this solution called Malleable Types. You can declare, in Kotlin, you can declare two kinds of types, without question mark and with question mark. If you declare a type without question mark, that means you cannot store null reference there. You can either store, you can only store the exact value in this type. If you declare the type with question mark, like here, you're allowed to store null references there. And if you try to dereference the first type, the first variable, that is declared with just string, there is no problem. You can do that. Everything is OK. But if you try to dereference the second variable with question mark, the compiler knows that, OK, this variable can be null. So it doesn't allow you to just dereference it. It says, OK, check that explicitly. And Kotlin provides several syntactic ways how to check that something is not null to have a concise and useful code. For instance, you can do this thing. You can just check it explicitly. So you can say if variable is not null, then dereference it. Alternatively, return null. But this almost the same you can do in Java. But in Java, if you check every reference on every access, that would be too verbose. That will become unreadable. So Kotlin provides nicer ways to do the same thing. For instance, here we can replace this one with the reference with question mark. So there is new operator, question mark dot, and that operator means exactly the same as this if. So it's explicit from, this one is concise from. So whenever you see this question mark dot, that means that if something is null, return null as a result. And even this small feature allows you to express your code in a much more concise fashion. For instance, in Java, so what do we have in this example? We have client. This client has personal info. Then in personal info somewhere we store an email, and everything can be null here. So in Java, we have to check everything. So we have to check that if client is null, do something, return. if personal info is null, then return. If email also can be null, then return. And only after we check everything in this chain, we can do what we wanted to do. And Kotlin allows to express the same so Kotlin allows to chain this question mark, the references, and to express the same in one line. So this means exactly as this example. So that means if client is not null, return personal for, otherwise return null here. If this personal for is null, return null or return email, and so on. And this is the way to provide the default value or to say what to do in the case of null here. And we can do our action. Under the hood, nullable types are just annotations, so there is no performance overhead. They are no wrappers, by no means. So you can. So if you give these nullable types, it doesn't add any performance overhead to your project. Okay, now I've finished with my first two parts, nullable and concise. And now I want to discuss the expressive thing. And in a sense, expressive can be, so I can discuss lots of Kotlin features in this topic. Lots of things that allow you to become more expressive, to do things in a nice way, in a nicer fashion. And today, I want to talk about something new. Something that we hope will change how we do things in the future. Something that we try to foresee, try to provide, and also something that we hope would interest people to go for, to go for from Java, for instance, because that is something that can be doesn't have very straightforward replacements. So I want to discuss coroutines. Who have heard something about Kotlin coroutines, at least read? Oh, that's nice. So there are some of you. And for others, this will be very general introduction. I will introduce you to the general idea of why do we need this and what's hidden, what is the key idea hidden in this functionality. And afterwards, you will be able to decide what you want. So for now, these coroutines are actually in experimental state. So they were added as a key new feature in Kotlin 1.1, but the final release will be very soon. So for now, we try to gather as much feedback as we can from the community. So we want people to try them and to provide some feedback, because it is really something that changes the way how we do things. The Kotlin coroutines, they bring the support of some features that were known in other languages already for a while. For instance, it brings support of async await and yield construct. Async await is a construct that was used in C# for some time. Who is familiar with async await from C#? Oh, then it means that you'll see how it looks like in Kotlin then. You'll understand it. And also, coroutine support brings support not only for async await, but for other things as well. The initial term was known for like many years now, and even so it was invented somewhere in the 60s. So we do not invent this term. We just have the idea, the concept that is known already, and we try to implement it in the modern language. So let's see what we have as a result. Yeah, and Donald Knuth, in his book, he opposed the notion of subroutine, of main routine and subroutine. He opposed it to the coroutines who can call each other. So coroutines are something, they are like independent on each other, and there is no main thing there. So let's start with motivation and with the thing, why do we need this? we have this code. It's like loading image, and so we load image by some URL, and then we set image. And there is actually something wrong with this code, because loading image can be very time-consuming. So when you call this code, you can have a problem of blocking your application. So your user won't be happy if you write the code like this. And what is the other way we can express this logic? We can say, okay, now let we do loading asynchronously. Like we change the function. We say, okay, now we have load image async function that somehow starts this loading image in an asynchronous fashion. And then we say, okay, then we add the callback. And Java 8 adds this functionality. They add completable features, and then the ability to say, when this asynchronous computation is complete, please call this callback. So in a sense, we had very straightforward code, but that was wrong. So we tried to do it straightforwardly, but we blocked the thread. It was bad. And we had now we have another approach proposed by many frameworks, by Java 8 with completable features, by RxJava. And anyway, when you have a lot of callbacks, you can do the same. You can just add the callback after the computation is complete. So this is approach with callbacks. And what coroutine do is, in general, they try to say, okay, let's write this code as in the first slide, as we had it, like let's write it in the imperative style, very straightforwardly, like this, without callbacks, just as a method, consequent method, but somehow it won't block the thread. Let's say the magic is possible. So let's say, okay, let's continue to code in the imperative style, in the very straightforward way, just saying what to do after next, what to do after. But somehow this will won't have the problem of blocking the thread. And something here is added. Here, await is a suspending call that does some magic that allows you to not blocking thread. Again, I haven't explained anything about async await yet. For now, I just wanted to share the general idea. So why do we need these coroutines? Because we can replace all these callbacks with straightforward way of writing our code. So here we replaced back callbacks to just consecutive computations. Now, and again, this is very similar to C# language. In C#, they have special keywords, async await. Again, I haven't yet described what do they mean. In Kotlin, we do not have the same keywords, but we have async and await as a functions. So the code looks very similar to C#. So in a sense, you can develop as in C#. But in Kotlin, we have the language support for something called coroutines under the hood, and we can build async await as a library. So it's not like C#, we don't add the feature of async await, but we add the feature of coroutines. Okay, now let's go to some explanations from my side. Yeah, because now you should be interested in, okay, what's going on? Why this async await allows us to replace these callbacks with just consecutive computations. And let's start with just general discussion about threads and coroutines. How can you do asynchronous computations in general? The very naive and simple approach would be just create new thread for every computation. And this will be my notation. I will write the thread is this line, so the lines will be the threads, and the computations will be blocks. So I will just use this notation. So we can start new thread for every computation. It's very naive and the very first thing that you probably have done some time ago, but that's too expensive. And actually, this can be done for some type of computations when you just don't care about the performance or just prototype something. That's possible. But thread is an expensive thing. Thread consumes up to 2 megabytes of memory. That's quite a lot, and you just cannot define lots of threads. You just cannot have too many threads in your system. The solution that was proposed to Java 6 or 7, okay, we can have a special executor that has fixed number of threads, and you can add tasks to this executor. So executor have these threads. It can be fixed. It can be dynamic, but still executor possesses these threads, and you just add tasks. However, it's difficult to manage dependencies in this case. RxJava and compatible features of Java 8, they allow you to manage dependencies, but before this, that was very difficult, and with them, it's still callbacks. So now, we are closer to the concept of coroutine. Coroutine is a lightweight thread. What do we mean by calling this, by saying the phrase, coroutine is a lightweight thread? This coroutine is a computation that can be suspended and then returned back. What does it mean in this picture? That means that we can have the threads that some computations on them, and at some point we can suspend the computation. We can take this computation and put aside. It can wait for something, and then we return it back. So this means actually that computation can be suspended. And it is crucial in this new Kotlin coroutine design. It won't change. So even after release, you'll have this concept. It's suspend function. It's not a suspend fun or anything. It's just a suspend function. So if you in your code in your Kotlin code see this word suspend, then it means that this function is a computation that can be put aside, that can be put away from your executor, can be suspended. Why is it important? Why it's crucial? Imagine we have, again, back to threads. Imagine that we just imagine that we write very straightforward code. We start from our thread to other computation, and then we wait for them, blocking the thread. When they're finished, we can continue. When the thread is waiting for that, this thread is idle, it's blocked. So this thread is busy with waiting. It cannot do something else. It just has to wait. It's wasted in a sense. So we can't do other computations here. So this is our first, similar to our first image example. When we tried to say, write straightforward code, it was very clear, very concise. However, it was wrong because it blocked the thread. If it's UI thread, that is even worse because your user is blocked as well. Your whole app is blocked. A user can go read Facebook at the same time, but still, it's a bad style. So this is too expensive, blocking the thread. But so we can write straightforward code, imperative style, but blocking thread doesn't give us anything. Compatible features, or RxJava, or some other frameworks, they try to solve this issue by saying, okay, move end of your computation into the callback. So now you divide your computation into two parts. The first part starts this, and the second part is in callback. It's separate, and you can start it when these two are finished. So this is, in a sense, our second image example with callbacks. So we moved computation in a callback. Okay, now we are very close to the why, to the how it works. How do coroutines work? Coroutines, again, coroutine is a computation that can be suspended. So why it is important in this example? Again, we have some computation that starts two new computation. So like we have this blue one that starts the green one and the red one. And then instead of blocking the thread while waiting until these two computations are finished, we can suspend this one. And then after it is finished, return it back. And that's how we can express the first computation. We can write our computation in an imperative style, very straightforward, like before, like when we blocked thread, but under the hood, it won't block the thread because it will suspend computation. So we just replaced these blocking threads with suspending computations. And this allows you to write logic very similar to what you had before. So now let's go back to the image example and explain how it works. So here we have just load image asynchronously, this function that starts asynchronous computation and does some work. And we have another function that starts this asynchronous computation load image async. And then there is this magic await. And await is a suspending call. So I have shown you that, okay, we have these await special suspend functions that can suspend computation. So whenever you see suspend function in Kotlin, that means that this function triggers this putting await. So it's how it's defined. So here, if we go and see declaration of await function, we'll see this suspend keyword. That's what matters. And back to our example, we have load image async, await, and then do something else. And there is this our first computation process image, the blue one. And it starts the new computation, the green one. And while it achieves await, in this case waits, but in general it's when it achieves calling suspend function here, that means that this suspend function suspends computation. So calling suspend function triggers this putting await of a computation. That's what matters. Afterwards, after the computation is suspended, we can return it back. We can continue when the result is ready. So instead of blocking the thread, we just suspend computations. And just this key idea allows you to express your asynchronous computations in a much more concise fashion, in a much simpler way. You can ask here on which thread the computation can be continued here, because you see there is several threads, and there might be a question, will it be continued on the same thread or on another thread? And the answer is that you specify that. Actually, I've kind of lying for all previous examples, because in Kotlin, if you call the async function, you have to, for now, explicitly specify the context where the computation will be called and also continued. So you can use the common pool, that is forkjohn pool under the hood, and in this case, the computation can be continued on any thread on a pool. Or alternatively, you can specify the context for calling your computation on the UI thread, and in this case, your computation will continue on the UI thread only. And you see, in the meantime, when you suspend these computations, so why it's so important? What do we want? For why this idea is so crucial? That when we suspend the computation, your thread might be busy of doing something else. So you can have other computations going on the same thread. That's a crucial idea. That's why we want all of this. If your computation is, the suspension might not actually happen if the result is available already. For instance, you can start this load image as async, and then at the same time, on the same thread, you can do other work. So your main thread might be busy, and in this case, when it achieves a wait, your other computation is already finished, so you now don't need to suspend it and return back. You just can continue from as before. So now it gives you much more power to manipulate your computations. Another thing that can be achieved by the same coroutines support is yield. I will give you just a small example. This was all about asynchronous computations. So I've shown you just one example of what can be expressed here, but this example showed you the general idea of why it's crucial and why it changes the way how you write all this logic. So I've shown you how, in general, these computations can be expressed in an imperative style. So yeah, another thing that can be achieved by using by having the coroutines support in the language is yield. And this is not about asynchronous computations. This is about generating sequences. And you can, here in this example, you can build sequence by yielding values when they are necessary. So if you look closely to this example, at first we build sequence and yielding by loading some data to elements, and then we print these elements. And if you see on the output, at first we're loading the first element only when it is necessary, only when we require for that, in this second line. And then when we require for the second element, we load it. So that happens only consequently. That happens only on request. And this yield under the hood is implemented very similar to, so under the hood it relies on the same coroutines support for the language. So again, the general idea that is supported in this last release for the language is that, okay, on a language level we have coroutines support, and on the library level we have lots of things. We have async await. Can I ask to close the door, maybe? Because now we're very close to the finish, so we have 5 more minutes left. I will just have a slide and some references, but still we have, it's better if it's, thank you. So we have several things in the library. We have async await, and actually in the library we have more things supported. Yield. So we can define channels, we can define lightweight actors using the same coroutines feature. So coroutines is a powerful feature that adds more value to using this language. We have a magnificent guide describing coroutines. So if you're interested, you can just read this guide to Kotlin coroutines by example. It's very easily findable. And I want to mention that this almost all of the library was implemented by Roman Elizarov, who joined the project, the Kotlin team, half a year ago, and since then he did lots of things. He implemented the library. He also wrote lots of documentation that can help you to master coroutines. Yeah, this is how this guide looks. It's just a file available on GitHub. It has lots of examples. If you are interested, you can just look it through. Just some reference at the finish. So we have this Kotlin site. You can go there. Now there is another message on the top page, so the old page, sorry. You have, if you want to learn Kotlin, there is a nice way to learn it by, on this site, try Kotlin Lang. We have so-called Kotlin Quants. It's many short exercises that you can do one after another to learn different features of the language. And yeah, you can tweet about that. Also, we have Slack, so you can, if you're interested again in the language, you can join the Slack, and we have quite a lot of discussions over there. Okay, so thank you a lot. Have a nice Kotlin.
Thank you, Svetlana. Okay. While Roland Huss gets ready for his presentation, while he gets on stage, shall we take one or two questions very briefly? Anybody got any questions for Svetlana? Yes, we've got a question in the back there. Let me run to you.
Hello.
Hello.
So, what would be interesting if we could see any measurement, regarding your threads, the light threads versus the normal.
Sorry, I can't.
If we could see, maybe you have it somewhere in the back slides. So my question is, if we could see any measurements between your threads, light threads, and coroutines versus the normal old persistent threads in a real-world application. So I understand that loading an image can be convenient, since when you load a 2 GB image, it takes long.
As I said correctly, the question is about some measurements, about comparing threads versus regular coroutines. I'm not sure about that, but you see that it's not about so you cannot do the same with threads. So it's not about what is where the performance is better, but performance is better with. I will discuss about that. The thing is about how you write your code. So with threads, you cannot write the code without the support of async await or coroutines in this style. So you have to do either blocking or callbacks. And coroutines give you the way to express another style of coding. And about sometime kind of performance, I've already told that the threads takes like 1 to 2 megabytes of memory. Coroutine is very lightweight object. It's one object with a state, so it's several kilobytes maybe. So you cannot have hundreds of thousands of threads in your application because it's too much. However, you can easily have hundreds of thousands of coroutines created.
Okay, I was wondering about context switch. How you take back the thread that you just, make it wait, and if you measured that.
So the general idea is that context switch is much easier with coroutines because you just, so it's implemented it's implemented at the language level.
Yep.
So the language can can provide this support for doing it very easily.
Okay, thank you.
Thank you very much, Svetlana.
Thank you.
Awesome, thank you so much. Okay, so